Okay, so we're back online for the last session, and this afternoon we're going to talk about subject related to conservation, but also mitigation. So maybe in your case, rehabilitation. And so we'll start with Anaïs, and then we will have Maya with us, Luz, and Esther to finish the afternoon. So if you want to be here for Maya, you have to be here on site because after the presentation of Anaïs, we won't be online anymore. And for Luz and Esther, it will be just us. So to assess your work this afternoon, your jury members, Samuel Geglot from Nature Dive, Aldine Amiel from, I think you know, Université Côte d'Azur Aircon Lab, and Florence Lacrosse, who is here more as ACRI, as you know, of course, former student from Mares. I will be here as usual as a chair, so I'm not supposed to ask questions, maybe just for your curiosity. Okay. So now it's show time. You can go ahead.
So good afternoon, everyone. I'm going to be presenting my study of my immersion project, which was determining a successful repopulation program for the European spiny lobster, Palinurus elephas, in the Mediterranean. So for a bit of context, so the species Palinurus elephas is currently, and since 2013, classified as vulnerable on the IUCN Red List, and its population trend is decreasing. So before it was fished about 820 tons per year between 1960 and 79, and it is currently, and since 2019, fished at more than less than half of that number, 385 tons. So its fishing number is greatly decreasing. This is probably mostly due to destructive fishing practices as well as climate change. But this rare resource leads to a lot of destructive fishing practices as it is so rare to find nowadays. So it is important to replenish the stocks, as reestablishing the species would decrease these harmful fishing methods that also impact the ecosystem around, and it would also benefit the local economy, such as Corsica, which depend on this species for about 70% of its fishing revenue. So where can the species be found? It's mostly found in the Mediterranean, in the United Kingdom and France on the Atlantic coast, and in Portugal and also the Azores. So for a bit of information that was important for my research, we've got its habitat. So it's usually on the offshore seabed. We can find it on open coast up until -400 meters in the sea. It is usually found in small or large boulders and wrecks, and anywhere where there's somewhere they can hide, small crevices, etc., so they can be sheltered. For their molting and growth, their first year post-settlement, they molt about 8 to 12 times, so there's a fast growing. And after that, they molt about 1 or twice per year when they're adults, after once they reach the 2 years of age. So their male size can reach up to 60 centimeters, and female size about 50 centimeters. So to achieve a repopulation program for this species, I worked with Lagosta, which is a sustainable aquaculture startup in Monaco. And one of their new projects is this repopulation program, because they can master the breeding of these individuals. And when the breeding happens, they have eggs and they can directly release larvae into the ocean to help repopulate the coast for this greatly depleted resource. So to create a repopulation program, I looked at different studies to see if it was possible and if something like that had already been done. And I could see that in Foyesa et al., there were spillover effects in marine protected areas when they tried to replenish stocks of the species. So there was a 500% increase in the European spiny lobster between 1997 and 2009. And individuals were also found 50 kilometers away from the center of the reserve, so a lot of spillover. In another study, there was a 300 to 700% increase in the stocks after implementation of fully protected areas. So when stocks are trying to be replenished in protected areas, there's a very large and fast increase. In terms of aquaculture, there was also a successful study in Stellamar, which is in Corsica. They obtained 6 juveniles in their aquaculture system, so it is also possible to replenish stocks, but through aquaculture. So what was I trying to answer with my study? What was I trying to do? I was trying to determine a successful population program for the species in the Mediterranean. The optimal program would hypothetically answer to optimal habitat, favor population growth away from pressures, so in MPAs, and the right program would also prioritize population growth and lower mortality in the ocean. So now for my methods. So this was my study area. I mostly looked between Monaco and Fos-sur-Mer because over here we have some protected areas, notably Porco. And these were areas closest to Monaco because further away would engender too much of larvae death in transport. So it was more beneficial to look at a smaller study area. So now to start with the different projects. So I analyzed 3 different projects, Project A, Project B, Project C, and all of them had different methods. So Project A was modeling larvae dispersal to monitor population growth. So this project was directly taken from Lagosta. They had already a project in plan to release larvae, put them in the ocean, and then after a few months go and do underwater visual census to see if the population had grown. But we thought it was better to install a dispersal model to simulate how the larvae would drift on the Liger current that passes in this area of the Mediterranean and see where they would end up, if they would end up in an MPA or not, and if they did not, would it really be beneficial to do this project or find another one? So that would be the first step in Project A. Project B would be the rearing of larvae at Lagosta, and then the release at strategic points so that they could drift into an MPA. And the end goal would be to have an increase in the population growth and be able to monitor the species with underwater visual census. Now for Project B, the step of the rearing larvae would be the same, so that would happen at Lagosta. There would be a creation of nets with the help of Ecocéan, who are based in Montpellier, and that picture is from them. They already do a project like this where they release larvae in underwater nets, and the larvae grow without any predators. And then they do this for fish, not with lobsters, so it's a little bit different. But when the fish grow enough to fend for themselves or be a bit more healthy, then they release them from the nets. So my idea in Project B would be to do that with the lobster larvae, so they could benefit from natural cycles of the ocean. And once they reach the juvenile stage, about 6 to 9 months after the larvae stage, from the beginning of the larvae stage, then they would be able to settle on safe substrate that we would put the nets on. So then the end goal would be the same as Project A. It would be to have an increase in population growth and be able to monitor them. So the benefit with this project would be that we could put the nets wherever we wanted. So in the right area with the right substrate would be good for them. And then we can put them at the distance we want. So maybe 15 meters would be good. It's usually good for juveniles. So divers can come regularly and maybe clean the nets if it's clogged by microalgae or other things. So now for Project C. Project C would be a bit more complicated. It would see the mastering of larvae growth within Lagosta and releasing juveniles directly instead of larvae. So for this, the first step would be material acquisition. We would need more filters, more aquarium, more nutrition. Currently, Lagosta masters only 60% of the larvae life cycle. So it would need to reach 100% to get to the juvenile stage. So then the larvae would be reared by Lagosta, and then they would be released at strategic points that would be more beneficial for them, such as the National Park de Porco, which is circled at the top right. And then the end goal would be the same. It would be increasing population growth and being able to monitor them through an underwater visual census. So how did I compare all of these projects? So I chose 5 different parameters, which were the same for each Project A, Project B, Project C. All the parameters were the same, all of the variables were the same, so that everything could be standardized, and they were given a score from 1 to 5. So here we have the risks. So I chose 4 main risks, or mortality of larvae in lab, material malfunction, vehicle breakdown, which would be the complete loss of juveniles and larvae, and the survival rate of juveniles or larvae in the ocean. The next variable was the time to implement. If it took 1 year or less, the score would be 1, 2 years, the score would be 2, and so on until 5 years or more. And then the estimated population growth, I based myself on the average egg batch for each female, which was about 112,500. and the mortality of the in the ocean of the larvae to the juvenile state, which was very high, about 99%. So if we did the calculation, then at the end we would have 1,125 juveniles per female. So if it was that number or more, then it would get a score of 1, and then I decrease by 25% to kind of still have the threshold, but still increase the scores. And at the end, the lowest score would be the project that would be the most beneficial to population growth. The next variable was cost. So the base budget for Lagosta was 173,000 euros. So that was a score of 1 because it would be the less expensive. And then I added 25% as they still need to get the budget from somewhere, and it's always hard to get funds when you're a startup. So each 25% increase would have a score increase as well. And then the monitoring ability, that looked at how long it would take to get to the implementation spot. So as I mentioned, the National Parc de Porquerolles, that is 2 hours away. So as we'll see later in the results, that would get a score of 5 because it's very, very far, and it would reach the 70 minutes or more threshold. So now for my main results. So project A, as a reminder, it's modeling larvae dispersal to monitor population growth. So the risk was attributed a score of 2. And the main risk was the uncertainty of larvae dispersal without a model. So right now, there's no model to dispersal to simulate the dispersal of larvae. So we have no idea where they would end up, and that still needs to be made. So all the other risks were given a score of 1. This one was given a score of 5. So the average was 2. And to base myself on how the Liger current kind of works in our area of the Mediterranean, I analyzed a study which was done on copepods, which are much different as larvae. But we can still see that they drift along the coast, and they're kind of in open water, but they're also kind of around the coast. So it would be a general idea of how plankton work around the current, how they're impacted by it. So we can say that there is a chance that this project works because we can see that there's a drift that goes along the coast, so we could be fine. But still, we need a dispersal model. So for the next parameters, for time to implement, we had a score of 1 because it was very short. We would only need the 5 months of egg incubation. The estimated population growth was a score of 1. We would get about 116,500 juveniles every 5.41 years. That relates to the time it takes to reach sexual maturity for females. And the cost would got a score of 1 because it's the base budget. And the monitoring ability, the implementation area is still unknown because we don't have a model. So we got a score of 5. So this was the table, and we got the average score of 2 for this project. So now for project B, the risk got a score of 1.25. The main risk was survival rate of larvae in nets is unknown. And the holes may become clogged by algae, which would reduce how much phytoplankton and zooplankton gets filtered through the nets, and if the larvae can eat enough. The time to implement was a score of 1 because it's very fast, 5 months. Estimated population growth was given a score of 2 because it's unknown, but because of previous research, we think that since Ecocean has done this for many larvae of fish, they have done this in multiple projects, so we have a good estimate that it can work, but for now, there's no numbers. For the cost, it was given a score of 1 because the budget doesn't increase that much. And monitoring ability was given a score of 5 because, as I said, the Parc National de Porquerolles is about 2 hours away by car. So here was the table, and the average score for this project was 2.05, so very similar to project A. Now for the last project, was mastering larvae growth within Lagosta and releasing the juveniles directly in the ocean. The risks got a score of 2. The main risk was high mortality rate. Based on the Stellamar study, they only got 6 juveniles, and implementing 6 juveniles is not very good because they may die instantly, or they can find a way to hide and live. The time to implement was also given a score of 5 because the time to get machinery, to set up everything, to get engineers, etc., it can range from 5 months to 6 years. So not taking any risk and getting the higher one, score of 5, but this can also change. The estimated population growth was a score of 2 because if we estimate that most of the juveniles released did survive when they reached sexual maturity, then we would get a population growth of 965 juveniles after 5 years and 5 months. The costs were very high, so a score of 5, and the monitoring ability, same, Parc National de Bordeaux was deemed the best one, so it was given a score of 5 because of how far it is. So this was the end. The number in the top right is not the right number. I think I did a copy paste, but 3.8 would be the general average score given to this project. So now we have our 2 elected projects, Projects A and Projects B. So these were the ones that were the most similar, the lesser scores, but as they are very similar in score, 2 and 2.05, I estimate that it was important to keep both of them. So now for a bit of discussion. So Project A, as I said, it looked only on copepod dispersal to get an estimate of how well it would work. So the drift would bring plankton to the southwest of France, or they would end near Nice, or they would kind of continue to drift along. So eventually this can become way too far to do an underwater visual census, especially if they get to the middle, to the open water, and it's very deep down. The divers are not going to be able to go and see which lobster is where, etc. So it gets a bit harder. Not to mention that copepods are also significantly smaller than spiny lobster plankton, so they can drift faster, or it's just a whole different kind of movement on the current. And also, copepod life expectancy was about 6 to 9 months, whereas at the end of the 9 months, the juveniles would already be settling down to the sea bottom. For Project B, the rearing larvae in submerged nets, we were positive that nets would allow nutrition as they have been used by Écocéan for fish. And if the nets did become clogged, as that was our main risk, the divers can come down and scrub nets to allow more water to cycle through. However, there is a lack of previous studies for this project. It requires a lot of trial and error to estimate the real population growth. But we think it would be beneficial for a repopulation program, as it would have a reduction of predators, insinuating a higher survival rate than Project A. And lastly, for Project C, so the previous study was done by Stella Mar in Corsica. They obtained 6 juveniles, and that is a very low number compared to the estimated juveniles in the wild, which was 1,125 for each female. It requires more investment, and they could be exposed to potential disease outbreaks, bacteria, etc., even in the tanks. However, they would have protection from predators at sea more than larvae. So that's compared to larvae, as they would be able to directly go find shelter for themselves. And we can decide the implementation spot for the juveniles ourselves. So our future perspective and the conclusion. So since both projects were deemed to be perhaps good, we still need to develop a dispersal model for Project A, and the population growth is promising only if juveniles settle in MPAs away from the most pressures as possible. And Project B needs a trial and error on submerged nets, because right now we don't have enough information to know if it could work, but it seems promising, seeing as Écocéan has done this for a lot of projects. So in general, more research and probably a larger comparative choice analysis needs to be done with more variables, more parameters, so that we can compare a lot of different things and reduce the chance that we would get such a similar score. And who knows, maybe 2 of the projects can be done simultaneously, and we can compare how population growth differs from project to project. So I would like to thank Sébastien Perez, who was my supervisor at Lagosta, and the Marius team for regular catch-ups and support on the report. Thank you.
So here we go. So we'll try to follow an order. We can start with you, Aldine, for the questions. Then we'll go with Samuel and Florence. We will change with time.
Thank you for this presentation. So what is a successful repopulation program for you?
So a successful repopulation program would be a population program that has the highest population growth rate at the end of it. So one that can sustain the resource, sustain the population, and get it to grow and grow more than the other projects. Basically.
Okay, and in your introduction, you showed 2 main techniques. You have the how to say, developing protection area, I mean, seems to enhance much more the population than to repopulate from human hands. So why spending time to do such development if we know that protecting area are already increasing so much the population?
Do you mean why do I have to do the research
on developing a successful dispersal program, while if you develop a protection program on site, it's already, we know that it's already super successful.
Because we need to know like which one is gonna, because we first need like an implementation one. So we need to know, because if we just release the larvae, they might not stay in the MPA. They might just drift and go to a different one, or they might just end up somewhere else completely. If we do the ones with the nets, then that one, we know that they're going to stay, but we don't know how the survival rate is going to be under the nets. So the initial, from the larvae phase, we don't know how it's going to happen. And if we just release juveniles, even if we put them in an MPA, there's no certainty that they're going to grow very far or have a very good population growth, because if we grow them in a culture site like at Lagosta, based on like Stella Mar, we would only get 6 of them. So that's a very small number to get to a very good population growth. Maybe they'll all die directly.
So because you are talking about the Stella Mar success, so how many times have they performed such trial?
I think they performed it once, and that was in 2021.
Yes. And I think, are you sure that around the world, nobody ever tried such development?
Well, based on the research I did, Stella Mar was like the first one to produce. Actually, now that you remind me, there was Stella Mar, that they're the only one in the Mediterranean, but I think it was in Japan. There's another one, another study that developed that were able to obtain phylosoma, so it's the stage before juveniles of this species and 2 other species. I think it was Jasus and Panuliris lobster species.
Do you know how many they, on this other species, do you know how many they got?
I don't remember the numbers exactly, but I think it was about 15 for Panuliris, so the species, and it was a bit more for the other 2. But it was less than 20, I'm sure of that.
Okay, so there is still, even if Stella Mar is managing to develop only 6, I think there is a lot of, improvement to do from maybe other technique, and then it can work. So that can change drastically your growth number. So regarding your project 1, you mentioned that you need this larval dispersal model. So what about population genetics in this area of the Mediterranean, and can the population genetics study can help you to develop a dispersal model?
I didn't really look into population genetics. What do you mean by that exactly?
You can follow where the population is coming from. The adult, are they, you can already know if they have a large dispersal zone or not. So I'm sure that somebody already looked at that in the literature. So can you?
For adults, they have like a homing ability of about 7 meters squared. So once they're adults and they're settled, they move in 7 meters squared area from their homes, go forage, and then they return at night. So they don't really go and migrate. They have their home, and then they go forage, do their stuff.
But in terms of genetics, if you analyze the genetics of this adult and the genetics of, an adult in foster than an adult in Italy. So can you, is there any study that link all this population, and how this data can help you to set up a larval dispersal model?
Probably. I'm going to be honest, I didn't look into the population genetics at all. I know that for this project, we would be using the lobsters that come from the Var, so from this area, so that there's like less of a mixing of genetics, so that they can kind of follow the general gradients of what happens around this coast, so in the study area. So we would only be focused on that. So we would work with the CDP in Antibes to get the larvae, so they would go and they would fish them for us, and then we would have those lobsters breed at Lagosta, and once they make eggs, we would get the larvae and we would directly release those into the ocean. So there's no differentiation in genetics. It's just var lobsters and that's it.
Yes, but it's another resolution of genetics. But okay, thanks. I think I'm fine for now.
For now.
Yeah.
Samuel.
Thank you, Anaïs. I have several questions. Yeah, my first point is about really the dispersion model, which is really for me a key element. We don't have any idea of how it's working when they are recruiting on the coast, how it's working, at what age? You said 9 months, 6 months?
They drift as plankton for 6 to 9 months.
6 to 9 months.
And then they settle as juveniles. So they kind of swim near the coast. They have their instinct. They kind of try and swim, and then they sink down and they settle on the ground.
On small, on shallow waters or deep one?
Juveniles, they go to 15 meters below seawater, and then as they get older, they can go to different up to 400 meters deep.
Yeah.
But as they're juveniles, they stay at shallow waters.
And in terms of predators, do we know what is the level of predation and
Level I saw in one paper, the mortality rate was about 0.27 per year for juveniles. And that was in MPAs, and outside of MPAs, it was about 0.40, something like that. So that's the amount of mortality rate on the juveniles.
Okay. Did you talk with Ecocean about the idea of using their fishnet?
Yeah, we had a call with them, with my supervisor, Sébastien. And he was, we had with Gilles Lecaillon, I don't know if you know him. We had a call and he said it would be a good idea to do something like that. We wouldn't be able to do a kind of partnership with them, unfortunately, but they would be willing to teach us how to make the nets. So the same ones as up here, they would be willing to show us the technology, like how to make them, etc., so that they can. So that was good.
And the idea is to leave them all along in the fishnet?
Yeah, so we would get probably a bucket, put the larvae inside, go there, release them under the net, and probably have a safe, like artificial reef or like a substrate for them to attach to when they get old enough, so that they can directly be protected as they get to the juvenile stage. So that would be the idea. So instead of just a sandy bottom, it would be like a substrate for them to hide into.
So how long it will stay? You know?
6 to 9 months.
6 to 9 months, okay. So in terms of cost, did you take into account all this big time of cleanup, maintenance?
I think in my cost there was a bit of maintenance, but I think that was for the aquariums only at Lagosta. The cost for the scrubbing, if it becomes clogged, that wasn't analyzed yet. But because it's a risk, it could or it could not happen, and it depends on how long it would take it for it to happen. So that's something we would see later if this project was chosen.
Yeah, because all the costs you said for the different projects, so it's really about only the larvae part, not the monitoring, for example?
Yeah, the monitoring hasn't been included in the cost.
And it's for what? For 1 year? Because it's written 116 for the project A, for example, 116,000 juveniles every 5 years.
Mhm.
So it means that this cost 173K. It's every 5 years.
That would yes, every 5 years. So the development with the breeding, with the development of the larvae, that would be the cost for the 5 years. So that would be the cost. So after 5 years, that's when the larvae reach sexual maturity, the juvenile, and that's when they can reproduce. But they reproduce once a year. So I guess in the lab, it would happen once a year that they would be able to have larvae and breed.
And did you calculate the number of potential adults at the end per project?
Potential adults.
Versus the cost?
Potential adults, no. I only focused on the juveniles.
To imagine how will be the cost of one adult at the end.
Maybe we can So maybe we can go to you, Florence.
Yeah, well done for the comparative choice analysis. I have a few questions about the method in particular. So I don't know, are you able to flick between the slides? Can you go to slide 19, where you detail the different parameters? Yeah, so about the risk parameter, I was wondering, how did you come up with those bullet points? How did you choose what risks you would include?
So for me, these seem like the biggest risk that would lead to the most larvae or juvenile deaths. So the mortality of larvae in lab, that can happen a lot with different bacteria, different diseases. If they don't have enough food. So that can be a big problem. The material malfunction, if one of the tanks, they stop working, then we would lose all of our larvae. So that's also a big factor. The vehicle breakdown, that would eventually lead to a complete loss of juveniles while we're transporting them. So that was a big risk as well. And another risk was how well the juveniles or larvae were going to survive underwater.
Okay,
So I felt that those were the biggest risk to the population survival for the project. So that's how I did.
and was that based on discussions with colleagues or the literature? I don't know, were those, where did the...
Mostly discussed with Sebastian.
Okay.
And also depending on literature based on different survival rates and what would happen if this would happen, etc.
Okay. And if I understood correctly, the calculation for the risks,
I averaged, everything.
risk was given a score from 1, like the other ones, 1 to 5.
Exactly, yeah. Each of them had 1 to 5, and then I took the average.
Great. And so about the monitoring ability, for project A, if I remember correctly, you gave it a score of 5. Even though the location hadn't been chosen yet. So is that assuming that the location would be the worst case scenario?
No, that was because there was no monitoring area chosen, so it was given a score of 5 because I had to complete everything on the comparative choice analysis. I had to give a number, otherwise it would be biased compared to the other ones. So I couldn't give it a score of 1 because that would not be true. So I had to give it a score of 5 because it hasn't been implemented yet.
Okay. But that being said, it could, for example, if you were to find a location that is a more
Sure, it
suitable
could.
location than Forcro, that number could actually be lower.
Exactly. That's
Okay.
that's why that's what I meant in my future perspectives, that we still need a lot more testing in project A and project B to really get a real score at the end. Because right now both of them are way too similar and there's missing information on the survival rate in project B and the monitoring ability in project A. So since we don't have those two crucial informations, then a final project can't be chosen. So we would need way further testing on both of them first.
Okay. And aside from this further testing, what would you say are the limitations of this method you've used, the CCA?
Well, for the way because I kind of built it by taking inspiration from different CCAs online. So most of the parameters have been based on what I would deem like a score. So for example, the time to implement, 1 year or less, I put that score as 1. For the 2 years, I put that score as well. And that was the same for the cost, for example. So getting doing more literature research on like what score would really give like the correct grading to cost, for example, or to time to implement, like how much is the time taken going to really affect my study or my project. Doing more research on that could probably improve my CCA.
Okay, yeah, nice. I just have a final question, and it's, if you were Lagosta's project manager for this, which project would you choose, A or B, and why? Or both? Yeah.
I would choose project B.
Okay.
Because since it has been done a lot by Ecocean for post-larval fish, I think there's a large potential for the juveniles to like get protection from predators, get enough food from the ocean cycling, from phytoplankton, zooplankton, and I think there would be a big potential for them to be able to grow into juveniles and then directly be in their substrate, and maybe the substrate can be movable as well, and we can then place them in another area that's maybe better for their future growth. But there's more mobility, there's more like we can change, we can directly control what happens to the juveniles in that sort of situation, and that's why I think it's a better project.
Okay, nice, thank you.
I have one more question related to this one, actually, to that one. Okay, in a dream world for you, if you had to redesign an entire program totally, so what would you do?
Well, as I would choose Project B, I would stay with that one.
Is it your dream program? Because the score is
That's the one I would think has the largest potential, but I would definitely do a trial and error before, prior testing. I would get them to National Park du Parcours, get them to minus 50 meters in their optimal habitat, so rocky substrate, a bit of Posidonia, so that they have something to hunt when they're big enough. I would see how well they do in that kind of environment.
Mhm.
And something I didn't mention is that Lagosta has a traceability software, so they can take pictures of the juveniles, and based on their patterns on their shell, they can recognize them directly. So they have AI, and then
for
take
how long they can organize that?
for how long?
Well, yeah, when you're talking about this pattern, so how long the
So-
pattern lasts on the animal?
When they become juveniles, they start having that pattern. Oh, and when they shed, it's the same pattern.
Okay, so it's a life pattern.
It's a life.
Yeah, it's their identity.
Exactly. So since we would be able to get to minus 15 meters and have divers take pictures of them, then we can directly send those images to the software and then analyze them each year maybe. So we would know how long we're keeping the juveniles, how many are dying, how many are proliferating, etc. in that area. So I think for me that would be the best option.
Okay, so now do you think that you will have much more successful rates to maintain this animal into the wild by larva dispersal or by protecting the adult?
By protecting the adult, but by first releasing the larvae in a controlled space, but in the ocean, so it's still
Need both.
natural. We need both, but in a controlled state, not just flowing down the current.
Okay. Okay, thank you.
So you agree?
Hmm?
So you agree? You need both.
We need everything.
Thank you. Nice. Thank you. Congratulations. Silently or? Thank you. Nice. So we'll end the stream now. Only people on site can follow.